Hello everyone, I welcome you to this video. The topic for today is statistical characterization. In statistical characterization, today we are going to understand some important measures for understanding dispersion of our data. We are going to understand these topics while solving certain questions. We are solving first internal test Part A, Statistical Characterization. My name is Manas Pathak. I'm a student of IIPS DAVV and we are solving the first internal test. So the first question says, give three more commonly used statistical measures for characterizing dispersion in student feedback data. We are given some examples which are variation teaching quality scores, lab facility ratings, or peer collaboration effectiveness. Discuss how these measures can be computed efficiently in large student databases. So basically in this question we have to discuss three measures for characterizing dispersion of data. Then we have to relate them to the given example, and at last we have to discuss how these measures can be computed efficiently in a large student database. So moving on with the solution, the first statistical measure is range. It is a common statistical measure used for characterizing dispersion. It is calculated as difference between highest data point and lowest data point. It provides us with an idea of how big and spread out our data is. So basically what range is, if we arrange all the data values in an ascending order, then the difference between the values at two extremes would be my range. For student feedback about teaching quality, small range indicates most students have similar opinion on teaching quality, and a large range would indicate that the students' opinions are varied on teaching quality. Range can be simply calculated using database management system softwares that provide minimum and maximum functions. These are the inbuilt functions which tell us about the minimum and the maximum values in our data set, and then we can simply calculate the difference of these two values to get the range. The next statistical measure is quartile. It refers to the four quantile values which divide data into four equal parts. So basically what quantile divides our data into n equal parts. And when we talk about four quantile values, these values divide our data into four equal parts. They give an indication about distribution, spread, shape and center. Three quartiles that divide data into four parts are Q1, which is the lowest 25% of data, also known as 25th percentile. Q2, it is actually the median of the data, which divides our data into two halves. It can also be considered as the lowest 50% of data or the 50th percentile. Q3 is the lowest 75% of data or the 75th percentile. Using quartile measures for lab facility ratings can help us understand where majority of student ratings lie. So if my Q3, which is my 75th percentile or the lowest 75% of data, if the value of my Q3 is below average, then I would consider that the lab facility ratings are most of the students have 75% of students have rated the lab facility as poor or below average. Several database management system softwares provide methods for calculation of quartile. We can also use Pandas library of Python to calculate the same. So basically, as I told you, the advanced database management system softwares have inbuilt methods for measurement of minimum, maximum, and even the quantile and quartile values. Also, we can use the Python libraries which are Pandas and NumPy, which are dedicated for statistical analysis. The third statistical measure is interquartile range. It is the difference between third quartile and first quartile. It covers the spread of data in middle half of distribution. So as we have discussed in the previous slide, the Q1 and Q2, the first quartile and third quartile, which are basically the lowest 25% of data and lowest 75% of data. When we take difference of these two values, that then we would get the middle range, middle 50% of data, because 75% minus 25% would then we would be left with the middle 50% portion of our data. So this tells us about interquartile range basically tells us about the how how our data is spread in the middle half of distribution. Its formula here is Q3 minus Q1. Calculating interquartile range helps us on focusing upon views of middle range of peer collaboration effectiveness while neglecting the outliers at the extremes of distribution. So basically this is the main advantage of interquartile range, that using interquartile range we can neglect the outliers, which are basically the values at the extremes of our distribution, which are very less in number. Interquartile range can be calculated using its formula in databases. So like I have already told you that we can calculate quantile or quartile values. So after finding out them using inbuilt methods, we just have to find the difference of Q3 and Q1, and then we would be left with the interquartile range. So this was all about our first question. We have successfully solved this question. In the next video we are gonna see some more statistical measures, the link for which would be provided to you in the description of this video. I would like to express my gratitude to Dr. Shaligram Prajapat, who guided me throughout the semester for my data science subject. If you gained some some informational insights from this video, consider liking this video and subscribing to my channel. I'll see you in next video. Thank you.